So very good morning to all the viewers who are watching my video at present. This is Padhi from the team of Mr. Nice. So as per the request from my viewers, some of have a doubt and clarification about how adaptive filters have been used in LabVIEW. So whenever we are going to discuss about LabVIEW programming, then we should have to know and we should have to get aware of how filters are being used for generating different signals. For in this video, I will be explaining everything in details to you about how we can cancel a noise, how we can generate an impulse signal, how we can give a frequency to our different filters, not only adaptive filters but different filters. There are different filters which are been available in LabVIEW, but still we will be using different frequency level, at what frequency level, at what disturbance it should be creating to adjust the frequency, to adjust the phase, to adjust the angles which has been present inside the LabVIEW. So let me have the explanation about adaptive filter for noise cancellation in LabVIEW. So let me have that to you. So when we discuss about adaptive filters, it is a tool or toolkit which has been available in LabVIEW programming itself. So before that, I have also been displayed a clear pictorial description of how the adaptive filters are being useful. So when we discuss about adaptive filters, then we should have a specified signal. So based upon that signal itself, we will be generating, we will be propagating, or we will be having a understanding about what signal or what phase, frequency, amplification we should have to use. For an example, if I am using sine signal, there is different frequency, there is different phase. If I am using cosine signal, there is different frequency. Based upon that signal, we will be stipulating, we will be changing, we will be having the understanding about what frequency we should have to keep such that the filter can process fruitfully. So those things we have to keep in mind, so those things we have to know. Okay, so that's the reason why I have displayed you in this video itself, that we should have a signal source. Okay, whether it is a sine, you know that. So we have studied in log systems itself. So then after a primary input which is of s plus n. So then after noise source. So usually noise source is present everywhere, but the disturbance we should have to cancel from this. So this usually plays a very important role, that is called adaptive filters. So when adaptive filters are being useful, then we should have a summing point, then we should be having a summing point, because we should have to do these operation in the filter itself. Okay, so there is a advantage of using LabVIEW programming, because whenever we are using filters, if you double click on that filters, there is a sub vi programs. Okay, you might be having get an awareness of that we are using filters with sub vi programs. The inbuilt programs we should not have to change, only we have to change by double clicking the filters, and changing the frequency as well as amplification, phase angles. So that's the reason what we have to keep in for the fruitful output of the signals. So let me have I have make you explain about how actually it usually works. So let us read about how the LabVIEW adaptive filters or toolkit which has been performed for this operation. So we have also analyzed the performance of adaptive filter to ensure they meet application requirement. Our application is to cancel the noise. So to cancel the noise, we have to create an adaptive filter by using appropriate algorithms. So what are the algorithms which is already even present inside LabVIEW? We should not have to do much more things on that. Okay, to specify approximate filter length, one is filter length, then after filter size or step size, and then after other parameters, okay, to specify the algorithm. So what is the algorithm? So when we have word filter, adaptive filter, then we should have to know we are using impulse signal. I'm clear cutting, I'm saying you clearly that we will be using impulse signal for generating the adaptive filter output signal. Just keep in mind, we are using what signal? Impulse signal. Unless and until we will not be using impulse signal, there is much more disadvantage of what frequency we have to keep to get the output signal. That's also we have to keep in mind. Whether we are using sine, cosine, it doesn't matter, but still we should have to use impulse signal to test, to verify. Okay, that's the main reason for that. So using adaptive filter and update coefficient vi, okay, to stimulate the adaptive filter. If adaptive filter is filter xlm adaptive filter using ft signal, then after update coefficient to stimulate the filter. So these are the real world application of how adaptive filter usually works with. Okay, so let me have you the signal coefficient or the figure which is been shown here, so make you understand about how actually it works. So everyone knows that how to know how to stipulate the for loop. So even you can stipulate in for loop or while loop, it's all depend upon your programming interface, but still we'll be using here to generate this signal. So just you should have to just we know that how actually block diagram is usually useful in LabVIEW. So create this filter. If you double click on this LMS, then this LMS or LFT filter, you will be having a sub VI program. Okay, so then after a filter signal and update coefficient, then after destroy FTF signal. So this is how we will be using the real life program to cancellation of noise. Okay, so this is how the adaptive filter usually works with. So I hope that you have got the sufficient information how actually it's been working, how actually the figures are been shown here. So let me have this this is an optional part, but let me have this for you all. Let me give an understanding about how actually it has been working, how actually it is usually been working with LabVIEW programming, LabVIEW interface. So using AFT destroy adaptive filter, why we should have to destroy? Because unless and until we do not have the noise cancellation ratio, the output ratio which has been even present, so it is very much difficult for us to generate which signal we are using. So that's the reason why we are using destroy adaptive filter or AFT, destroy adaptive filter in the LabVIEW programming. So I hope that you have got an idea about how usually we will be using for cancellation of noise. So what is the frequency? So when we are using impulse signal, what is the phase? Then that's the confusion which usually arises in students. So at certain frequency, at 20 hertz frequency we will be keeping, because it is an impulse signal, we will be having a ratio of 1. So phase will be 0 to 180, or we can say that. So to get an 0 to, because it's based upon, I have said it based upon the signal we are using, it based upon the signal amplification signal frequency. Unless and until we do not know the input signal frequency, okay, we will not be generating the output signal frequency, because input signal, whether it is sine, whether it is cosine, or whether it is any impulse signal, okay, whether or it is maybe any other signal, so based upon that frequency we will be calculating the appropriate filter frequency itself. So I hope that you have got an idea of how actually it has been working. So till then, thank you, thanks a lot.